What if I told you the biggest scientific breakthrough of this century might literally be sitting in a lab right now? And, well, almost nobody's talking about it. I mean, imagine a material that could completely kill energy loss. We're talking about powering totally lossless electric grids or, making quantum computers cheap enough to just run on your laptop. It sounds like straight up science fiction, right? But it's actually a very real concept called a room temperature superconductor. And looking around in 2026, we are way closer to this reality than you might think. Hey everyone, welcome to This Explainer. Today we're diving into a topic that has been sending massive ripples through the scientific community: superconductors. We're taking all these complex materials science updates and translating them into a clear, no-nonsense roadmap of our immediate future. Because, guys, this is literally the difference between the world we live in right now and a world with instant charging, perfectly efficient power grids, and levitating trains. Okay, so to keep us on track, here's our blueprint for the future. We'll start with the zero-resistance stream, move on to the 2023 viral fakeout, look at the real progress happening in 2026, and finally, break down exactly why this changes everything. Let's jump right into Section 1, the zero-resistance stream, and our fundamental battle against energy loss. So at its absolute core, a superconductor is a material that conducts electricity with exactly zero resistance. And what does zero resistance actually mean for us? It means zero energy loss, literally none. The current goes in, and the exact same amount of current comes out the other side without bleeding off into the surrounding environment. It's like a perfectly sealed pipe for electricity. In our current reality, pretty much every single wire you own, from that flimsy phone charger on your nightstand to the massive transmission lines outside your house, they all lose energy as heat. It's essentially friction for electricity. And this resistance is the fundamental limitation of our entire modern infrastructure. But superconductors, they offer a completely different reality. The electricity flows perfectly. Zero resistance, zero heat generated, zero energy wasted. Just flawless transmission. Okay, but there is a massive catch here. Historically, and up until very recently actually, these miraculous materials only worked at insanely cold temperatures. And when I say cold, I mean colder than outer space. Because they require such extreme freezing conditions, their everyday use is, well, heavily restricted. We can use them in highly controlled environments, think MRI machines in hospitals or those massive particle accelerators, but they are completely useless for your everyday phone charger or a standard outdoor power line. And that brings us to the ultimate holy grail of material science: achieving superconductivity at room temperature and at normal atmospheric pressure. If we can crack that, if we can make these materials actually work in the everyday conditions of your living room or out on the street, we change absolutely everything. We revolutionize energy, transportation, computing, the whole shebang. Which leads us perfectly into Section 2, the 2023 viral fakeout, famously known as the LK99 saga. You probably remember this blowing up your feeds. In early 2023, a South Korean research team claimed they had actually done it. They said they'd made a room temperature superconductor called LK99. And by mid-2023, this claim went incredibly globally viral. I mean, everyone was talking about it. Labs around the entire world basically dropped what they were doing and raced to replicate the results. But as we moved into late 2023, it turned out to be wrong. Global labs failed to replicate it. It was a false alarm. However, that wasn't the end of the story as we stretched into 2024 and 2026. Because here is the crucial plot twist that most people completely missed. This failure actually accelerated real research. Since LK99 went so viral, suddenly global attention, and perhaps more importantly, massive amounts of funding flooded into this highly niche scientific field. The internet hype died down, sure, but the money and the brilliant minds, they stayed. And that huge influx of resources takes us straight to Section 3, real progress in 2026, driven heavily by AI acceleration. Let's look at where the science actually stands today. Since that 2023 controversy, we've seen several completely legitimate breakthroughs happen. Now, just to be super clear, we aren't at room temperature just yet. But researchers are discovering totally new materials. We're seeing these materials operate at higher temperatures than ever before, and crucially, they're requiring lower pressures to function, so the needle is actively moving in the right direction. And the reason the needle is moving so fast right now is pretty fascinating. In the past, scientists basically had to test one material combination at a time, physically in a lab. You were baking compounds in a furnace, waiting, testing, and, let's be honest, inevitably failing. It was painfully slow. Today, though, research teams are using artificial intelligence to simulate millions of material combinations digitally. They're predicting atomic structures before a single rock is ever baked. AI is doing the heavy lifting, and it's literally cutting years off the discovery time. Now, the honest answer is that we aren't at the finish line yet. But because of this AI acceleration and all that new funding, the forecast has shifted drastically. Just take a look at this quote from leading material scientists. The timeline has moved from maybe in our lifetime to maybe this decade. I mean, wow. That is a staggering leap in optimism from the experts actually doing the work. So what does this actually mean for your daily life? Let's move into our final section, why this changes everything, and specifically the impact on you. Right now, our power grids waste up to 10% of all electricity generated purely to resistance loss. It just dissipates as heat into the air before it ever even reaches your house. A room temperature superconductor would instantly fix this inefficiency. That means our current energy generation goes massively further without burning an ounce more fuel. It's a total game changer. But the power grid is really just the beginning. If this breakthrough happens, your phone could charge instantly. No heat bottleneck to slow it down or degrade your battery over time. Remember how MRI machines need those incredibly cold temperatures right now? Well, with room temperature superconductors, MRI machines get massively cheaper and much more common, completely revolutionizing everyday healthcare diagnostics. Maglev trains, the ones that levitate magnetically and travel at insane speeds without friction, those become completely normal public transit rather than just expensive novelties. And quantum computers, which currently have to be cooled to near absolute zero in giant expensive facilities, they could suddenly become practical and cheap enough to eventually sit right on your desk. This isn't sci-fi. This entire list is just one single material discovery away. But let's ground ourselves back in the present for a second. Are we there yet? No, this isn't confirmed to happen tomorrow. But genuinely, we are closer to this reality right now than at any point in human history. The progress is real, the funding is absolutely there, and these AI tools are accelerating the race like never before. It is such a fascinating race to watch. Will this discovery come from a billion-dollar AI lab, or will it be stumbled upon by a lone researcher experimenting in a basement somewhere? Whoever cracks it is going to fundamentally alter human civilization. If you want me to do a full deep dive when that major claim drops, and believe me, it will drop, make sure to subscribe so you don't miss that explainer. Let me know in the comments, what major scientific breakthrough do you want me to explain next? Thank you so much for joining me to